This is video number 3 for sections 4.3 and 4.4, writing equations of exponential functions. What if you were given a table of information about an exponential function and you were asked to come up with the equation? This gets complicated, more complicated later on. In this video, we're just going to consider relatively simple cases. In fact, really, what these problems are just an opportunity for you to practice with what we've already learned about the role of the A and the role of the B. You might want to even try these yourself and then watch the video explanation. Okay, so we're given some tables here. We're being asked to do two things: fill in the blanks in the table and then write the equation. Well, let's take a look at this first one. We are told that in these three cases, we are looking here at exponential functions. Of course, you might be asking, how in the world can we fill in the blanks unless we already know the equation? Well, this has to do with that pattern that we had noticed, right? In an exponential function, if the x's are going up by 1, then the y's will always multiply by the same number. 2 times 5, right, is equal to 10. Well, if that's the multiplier here, it's just going to continue down. 10 times 5 would be 50 for the next blank, and 50 times 5 would be 250 for the final blank, and so on. I could keep going down if I wanted to. As far as writing the equation for the table, it really just boils down to figuring out the A and the B. If you can write yourself down the A and the B, you can easily write down the equation. The B we've already figured out. B is the base multiplier, that number that multiplies down the y side if the x's are going up by 1, so B would be 5. A, remember, is the y-intercept. So go to your table, find the spot where the x value is 0. The number that goes with it, of course, is the A. And so in this problem, the A, the y-intercept, is 2. As long as you've got the A and the B, you can easily write down your equation. You just have to learn the pattern. Remember, it's y equals A times B to the x. Here would be the final answer to the problem. Okay, let's try it again on the second example. Same thing, exponential function, fill in the blanks. This one's a little trickier, isn't it? The x's are going up by 1, so I should be able to figure out this multiplier over here. It's just trickier because I've skipped a line. I can see that to go from 1 to all the way to 4, I would have to go times 4. I need to figure out how to do times 4 in 2 steps. Well, 4 is, of course, 2 times 2. So if I simply multiply by 2 once, and then multiply by 2 again, that's the same thing as timesing by 4 once. That implies, of course, that this number here must be a 2. 1 times 2 is 2, 2 times 2 is 4, and 4 times 2 is 8. There's my table. If I can figure out the A and the B, we're all set with the equation. The B, we already figured out, is 2. A, once again, would be the y-intercept. Here it is in the table. Looks like a 1. And so my equation would be y equals 1 times 2 to the x. Now, we always simplify our equations. Multiplying by 1 doesn't do anything, and so this would simplify to just y equals 2 to the x. That would be the final answer. I find often that people get confused by this because if you were just looking at this and somebody asked you, well, what's the A and what's the B, it looks like the A is missing. Well, anytime that happens to you, you know that the A is this 1. It's there, we just don't write it in the simplified answer. Okay, let's look down then at the third example. Same thing, exponential function, trying to fill in the blanks. Now, I imagine when you glance at these y values, probably what pops into your head is it looks like there's a division pattern here. 18 divided by 3, right, is equal to 6. You can use a division pattern. Division is related to multiplication, so that's fine as far as filling in the table. If your brain says divide by 3, that'll work. 6 divided by 3 is 2. Of course, I could go on if I wanted to. As far as moving up the table, well, it's just going to be in reverse. If I divided by 3 to go down, I'm going to times by 3 to go up. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Now that I have the table filled in, I need to identify my A and my B. Well, here's where, even if you thought in terms of division, you have to think now in terms of multiplication. I need to know, what am I timesing by as I go down this chart? Well, one little sort of formula that you might find helpful if you're having trouble identifying the B is this. B equals y2 divided by y1. All this is trying to say is, if you're not sure what the B is, just take any y in the table and divide it by the y that came just before. That's what I mean by y2 and y1. Pick a y and then divide it by the y that came before. I chose 6 divided by 18. You could do 2 divided by 6 or 18 divided by 54. Of course, this doesn't go in evenly, but it does reduce. And the value that you get, that's your B. In this case, the B is 1/3. That makes sense, right? Dividing by 3. Think about how you work with fractions. We don't divide fractions, we multiply by the reciprocal. So dividing by 3 is the same as timesing by 1/3. There's my B. My A is very clearly here in the table. It's 54. And so now I have enough to write my equation down. Looks like the final answer, y equals 54 times 1/3 to the x. And again, I think especially when a fraction is involved, it's good to show that in a parentheses. The last example falls into the be careful category. I say that just because you'll be on a roll, you'll be working a lot of these problems, you'll glance at this table, and you'll say something like, oh look, the y-intercept is 3, 0, 3, and 3 times 3 is 9, so I guess the b is 3, and you'll write down something like this, 3 times 3 to the x. Well, that is entirely incorrect. And the reason for that is this guy, this function here, this table, this is not an exponential function. Okay, notice there's nothing in the directions for this one that tells what kind of function it is. If they don't tell you, then you have to choose. You have to decide. We've only studied two kinds of functions, right? Linear and exponential, so surely it's going to be one of those two. How do you tell? Well, the x's are going by 1. So then I look at the y's for a particular pattern. It is true that 3 times 3 is 9, but 9 times 3 is not 15, and 15 times 3 is not 21. That means this does not follow the exponential pattern. Is there a pattern with the y's? Absolutely. 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 6 is 21. That means this guy is a linear function. You don't really need to do much work to write down the answer as long as you understood those patterns with linear functions. I can see the y-intercept right here, 0, 3. And remember, if the x's are going up by 1s, the slope is that number that's being added down the chart. Well, that means the equation of this line is y equals 6x plus 3. Y equals mx plus b, right? 6 is the slope. B, the 3 is the y-intercept. So please be careful. Make sure you are testing out the function to determine what kind it is if they don't explicitly tell you.